Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests, and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Welcome to ARC's For Your Innovation podcast. That's FYI. Today we've got an excellent guest, Saman Farid, who's the CEO of Formic, a robotics as a service company. Welcome, Saman.
Sam, thank you so much for having me. Really excited to be here.
All right. So where's the first place we start when we talk robotics as a service? What does that even mean?
I think the main thing that matters about robot as a service is that we traditionally think of robots as like a piece of equipment or some kind of hardware that you buy. And the reality is that's actually not what it is. And that's also not what people are interested in buying. What people are looking for is some kind of outcome. That outcome could be, boxes moved onto a pallet. That could be some kind of welding scene being done. It could be the delivery of food on the road. It could be, 100 other things. But when we talk about robots, the problem is that they're kind of a means to an end. And I think when there's a lot of focus and emphasis on the robot itself, we miss the forest for the trees. And we end up thinking a lot about, well, what does it have this feature or that feature? Does it have this camera or that end effector? When the reality is what most people need when it comes to robots is the output. I think most providers of robotics until now have been providing the intermediary, which is the hardware. And there aren't a lot of companies that are out there providing the output. And I think that's where robot as a service comes in. It's obviously comes from software as a service, but I think the real thing about as a service is that it drives adoption. Right? If you think about the first kind of major wave of software as a service, like, CRM was obviously the most obvious one, but I like the example of email, because there used to be a time where if you wanted to have email for your company, you would have to hire somebody to do IT for you. You'd have to buy a bunch of servers. You'd have to buy internet bandwidth. You'd have to install all of that in server racks. You'd have to pay somebody to configure it all. And then after all of that effort and investment, you finally had email that you could use. And as a result of that, there was just no adoption, right? Like 95% of people in the world said, it's not worth it. I don't need all of that. And it wasn't until it became productized and it turned into a service that really you see kind of adoption happen at scale. And I think that's exactly what we're hoping for in robotics, is that moving to this kind of outcome-focused mindset and outcome-focused product offering is what will unleash adoption and what will drive adoption at large scale. Not at the scale of, like, most robotics companies today, and you talk to them, they're at the order of, 10 robots here, 50 robots there, maybe, the really extreme cases, they have 100 robots in one or two facilities. But we're talking about, what is it going to take to get on the order of magnitude of hundreds of thousands, or not, if not millions of robots deployed. It takes a totally different mindset and a different approach.
And so before we dive into the factory itself and what you're seeing, different applications there, maybe we start with the macro. And are you seeing any sort of inflection point here? When we talk about disruption, we normally say disruption and innovative technologies take hold during tumultuous times. And, COVID, definitely a tumultuous time. We have, supply chain shortages, definitely a tumultuous time. And we have wages that are increasing, making, the economics for automation better. Are you seeing more companies use this to change the way that they're thinking about things?
Absolutely. Yeah. I think all of the things you mentioned are tailwinds that are driving adoption in robotics. Or I should say those are all things that are driving the demand for robotics, but they're not actually driving adoption because it's been so hard. It's still so hard to get robotics deployed. But the demand is what you mentioned around kind of supply chain challenges. I think there's a few different layers of that. Even before COVID, we saw the trade war, and that trade war really pushed a lot of American manufacturers and American users to realize that they're very dependent on this global supply chain. Everything from tariffs to shipping to disease can totally disrupt their ability to procure goods. And so I think the first wave of that started with the trade war between the US and China, and it pushed a lot of manufacturers to want to bring manufacturing back to the US. And then COVID, I think, accelerated that even further when they realized that all these factories in the US are short-staffed and getting even more short-staffed. But this is also a problem that has been in place since before COVID. There are, I think, 1.5 million unfilled manufacturing jobs in America today. Not to mention all the other types of jobs that go unfilled, farm workers and construction and, the skilled trades. In every industry, you see an extreme shortage of labor. And that shortage of labor by itself, is one part of the problem, but it's also part of a vicious cycle because a shortage of labor leads to lower utilization. So like a typical factory in America runs 2,000 to 3,000 hours a year. That's out of 8,600 possible production hours. So they sit idle 70% of the time. So as a result, like every forklift, every truck, every CNC machine, every light bulb in that factory is sitting around collecting dust 75% of the year. So as a result, that factory has to charge higher prices for their goods. Those higher prices lead to less demand. Less demand leads to even lower utilization. And so you get this vicious cycle where it becomes harder and harder to compete unless you change some of the fundamental inputs to that equation. So like demand on manufacturers is going up, but they're unable to meet it. And that's why you see all these delays, right? Like there's a everything shortage in America today, right? And from metal parts to aircraft to food to, like anything you want to buy, there's a wait list. And so what we're thinking about as our company at Formic is like, how do we use robots to change that fundamental equation and solve some of those like inputs that, like you said, are tumultuous right now. But they're not just tumultuous right now, they're on a trend line of getting worse and worse. And we have to change the elements of that equation before we can get out of this kind of tumultuous environment.
Very interesting. And then, so going into the factory, maybe some anecdotes of some manufacturers who are having issues. I guess what are the barriers to robot adoption? Where has been an instance where you've gone in, tried to automate, and it hasn't worked. We're not there yet. And then where has it worked extremely well, and kind of the bread and butter at the moment.
The thing that we hear at basically every customer, every factory that we go to, is that they've been trying to automate for the last 10 years and haven't been able to. And the few fundamental reasons for that are, one, there's a significant amount of knowledge that you need in order to adopt automation in a factory. You need to know what type of tasks in your factory are suitable to automate, which is by itself very difficult. Then you need to, once you've identified the task, figure out what are the different components of that task and how would you automate it. You need to procure all of the different pieces of equipment that you need in order to do that, which means you need to shell out hundreds of thousands, if not millions of dollars. And then you need to, hire a variety of different vendors to customize it, program it, build end-of-arm tooling, install it on your floor, install compressed air lines, install power lines. There's 100 different things that go into getting the robot working. And then once you've got it installed and once you've got it running, chances are your need as a factory changes over time. Like you're running this part this week, you're running a new part in 3 weeks, and then in every few years you have to turn over your factory and you may have to do different kinds of products. And so a lot of factories end up with lots of equipment that sits in the corner collecting dust because they bought something that they needed a few years ago and they don't need it anymore. So either it collects dust or they sell it for scrap. And so it ends up being, very high bandwidth, very high complexity, very risky because you could buy the wrong thing. And, most of all, very, very expensive because you shell out, again, hundreds of thousands of dollars, not millions of dollars. There's a very big kind of information asymmetry between you as a factory and somebody who's trying to sell you equipment, because they want to upsell you. They're like, oh, you should get this feature and that feature and get a bigger robot and get more robots. And, they don't care because once you bought it, you may or may not need it, but they've already made their money.
You've aligned the incentives much better, I guess, as a solution provider.
That's the goal. Yeah. So, we came in and said, hey, these manufacturers may not be experts in robotics, but we are. So we know what to buy and we know how to buy it and we know how to install it and we know how to customize it. And it's cheaper for us to buy it for everybody and manage it for everybody than it is for them each to try to do it themselves when they're not robotics experts. And we've proven that thesis to be true because, like I said, a lot of our customers have been trying to automate, have been wanting to automate, and never got around to it or were not able to execute on that plan until we came along. And we were very proud to, for a lot of our customers, we're the first robot that they ever installed. And what happens often is once they see one robot working, they come back to us and they say, hey, I have like 10 other things that I need to automate. Can you please come and automate it? Then what we see start to happen is actually some of our customers used to run one shift a day because they could only hire enough people to run one shift a day. And then once we put in some robots, they suddenly are able to go up to 2 shifts a day and maybe eventually 3 shifts a day. So they doubled, if not tripled, the output of their factory with the same amount of labor. And that double or tripling of the output is actually more than double or tripling their profits because most of the costs of a factory are fixed costs, not variable cost. So all of those fixed costs stay the same, but you're suddenly selling double or triple the amount of product. Naturally, you see your kind of profits start to go up very quickly. And so it's a business proposition that's an immediate win for a factory. And we do it for them without them having to come up with a bunch of CapEx, without them having to hire a bunch of new, robotics experts or engineers, without them really having to change much of their production line. They literally point at the few things that they want automated, and we come in and solve that for them.
Great. So then back to part, I know is a multi-pronged question there. So what type of tasks have you had the best success automating, and which ones are still areas where, we're not quite there yet?
The short answer is the most common tasks that we've seen are, number one is palletizing. At the end of a production line, doesn't really matter what you make. There's usually somebody taking that product and putting it onto a pallet. So that's a really easy one to automate. There's a lot of machine tending. So that's robots that load and unload some other piece of equipment. It could be a CNC machine. It could be a spot welder. It could be a press. It could be a plastic injection molding machine. But there's robots that basically load and unload other pieces of equipment. There's a lot of robots that do different kinds of packaging. So things like case packing. There's robots that we've deployed that do things like welding. So welding is a really common need in a lot of metal fabrication. And then the other common one is inspection. Inspection is one where a robot actually really has a significant advantage when it comes to speed. We have customers where manually it would take 2 to 3 hours to inspect a part because there's so much detail that you have to inspect. And a robot with the right vision system can inspect that part in 10 minutes. And so you get this kind of order of magnitude increase in output capacity.
And then I'm wondering, I looked at your site, right? You're obviously, using all of the big robot manufacturers. You've got ABB, Fanuc, but you also have Universal Robots, right? And I think, when we started doing research on robotics a few years ago, kind of the big trend that we see is collaborative robots that can work side by side with humans, being able to help out these small batch manufacturing companies where, most manufacturing happens, or most manufacturing workers work in those types of environments. And, it was for traditional robots, about a third of the cost is the actual hardware, a third is, the peripherals, and a third is actually hiring someone to set it up. And this promise of, using AI, being able to train these super easily, we're not there yet, obviously. But what's kind of the dynamic that you're seeing in the use of collaborative robots versus more traditional caged off industrial robots?
Yeah, I think that that's a great question. It's been a line that we're straddling. We do applications that fall into both categories. Collaborative robots are really great for environments, like you said, where people have to interact with that robot, or where there's space constraints, because you don't have to put in all the safety fencing, and you don't have to put in as many like light curtains and things like that to cordon off the area. But collaborative robots right now have a lot of limitations when it comes to payload and speed. And so for some tasks, that's not a problem. And for some tasks, you end up kind of hitting that upper limit where it may not make financial sense to implement it unless you switch to an industrial robot. So I would say, I think the hype around collaborative robots was a little bit overblown in the sense that they don't really unlock a lot of new business value as much as people thought it did. There are obviously some use cases where collaborative robots are perfect, but today I think there's still a lot of applications where industrial robots just outperform collaborative robots so much. So yeah, I think we obviously use both depending on what the need is. There's also a lot of really cool technologies that are coming along that make it possible to use industrial robots in a collaborative way. So one example is a company that I'm on the board of called Veo Robotics, and they've built a camera-based solution that watches the environment around an industrial robot, and using those cameras is able to account for any kind of safety issues, and that allows a human to work in very close vicinity to a very, very heavy, very high payload industrial robot. So that's the kind of thing that I think technology is starting to enable, and the lines between those two are blurring more and more. And I think eventually we'll get to the point where every robot by default is collaborative, and not just collaborative between robots and humans, but more importantly, collaborative between robots and other robots, because you're going to have AGVs coming in and out of those robot work cells. You're going to have multiple robots working in concert to get tasks done, and they need to be aware of their surroundings and their environment in order to collaborate effectively. So I think that we have a ways to go from a technology perspective, but I think like we now have seen enough to know that path is 100% going to happen. It's just a matter of when. It's no longer a question of like, oh well, we don't really need cameras on robots. Like I think that question has been answered, and it's necessary.
Great. So let's go ahead and look into the future here, because it does seem right. The hardest part, as you're saying, is the implementation, the training, right? Once you get it set up, maybe you need something else. So how far along that path of ease of implementation using AI or ML from a robotics standpoint to say, okay, here's a task, here's the vision algorithm, we know what we need to do here, and we're not going to shut down this line for 3 months while we pay someone $100,000 to program this machine?
Yeah, I think there are some tools that we've started to see that make that process easier. But this is an area that I personally am really hoping that more people start to work on, because there are some people there are some tools that already exist, right? I think Ready Robotics, for example, has built a tool that makes it a lot easier to program robots. There are companies that have built tools for robot simulation. We use tools like RoboDK and Octopus and others that make it very easy to validate a solution in the real world. In the virtual world before you build it in the real world. And so, like each of those things knocks off some of the risk and some of the cost of getting a robot deployed. But there's still a lot in there that we needed to build ourselves in order to get robots deployed fast. So, for example, traditionally, if you were a factory and you wanted to deploy a robot, you would have to pay somebody to come in, and they would basically take weeks usually to measure a whole bunch of stuff in your facility and figure out what all the equipment is that they would have to interface with. Just that data gathering process was multiple weeks of time. And we've developed a relatively simple tool, but basically now whenever our team goes on site, We take a LiDAR scanner, attached to a couple of cameras, and we scan that customer facility, and we have a 3D model. So we don't waste any of their time. We don't disrupt their operation. We come back and basically overnight, we could try out 100 different robot models that may or may not work in that environment. We figure out, like what the motion studies are, what equipment they have to interface with. And we could basically the next day come back to that customer and say, look, here's what a robot might look like. Here's the throughput that we think we can achieve. Here's the size, the footprint it's going to take. Here are all the constraints. And that by itself like significantly shortens the amount of time to get a robot deployed. So that's like on the application scoping part. Then obviously there's the next phase, which is like if the customer decides to do this project, like we have to build that robot, we have to simulate that robot in the work cell, we have to generate all the programming for the hardware. We usually have to build some custom end-of-arm tooling and things like that. So that's also a process where we're building a bunch of software to automate that as well. But for most of these things, like our hope is that if somebody else builds the software, like we would much prefer to use something that somebody else has built than to build it ourselves. But right now, a lot of the things that we're describing around like making it easy to deploy a fleet of robots, other people haven't really built well yet. And then like once the robot is deployed, we obviously have to monitor it, we have to maintain it, we have to be able to remotely log in and do some teleoperation and resolve issues. And all of those are things that we've also had to build some of ourselves. But, I think this is one of those things where there's 100 little building blocks that you need in order to get a completely different outcome. And we are just kind of chipping away at that problem piece by piece by piece.
Yeah, it makes sense, definitely what you're saying. And it kind of leads to, obviously you want to defend your intellectual property with becoming experts in all of these various ways to set up various automation, but the need for the community to really come together and put out solutions and best practices as the industry is still emerging, which I always find fascinating, right? It's like robotics started really seriously in the 90s in manufacturing in the auto world, and we're still so early in that broad automation landscape, especially from a hardware side of it.
Absolutely. I think that there are technology problems that need to be solved, but more importantly, there's also a lot of very big kind of business alignment challenges that need to be solved. And I think it's not until both of those things are solved that we'll see this kind of wave of adoption. But the technology is happening. We've already talked about a few of the examples. Other people are building a lot of great stuff that will make it easier to deploy robots. And then there's the kind of business problem that we need to solve as well. I think those two pieces go hand in hand.
Yeah, I'd be interested to dive into the business side, right? Because Formic, there've been other robotics as a service companies that have tried to do it. I think each in its own unique way. So as you're running Formic, what have you had to pivot? What have you realized? What were the assumptions going in, and how are you thinking about it currently?
Yeah, I think that there have been robot as a service companies, and we, when I was a VC, we invested in a bunch of robot as a service companies, and I'm on the board of a few of them. I think that the challenge with robot as a service companies is that traditionally it's been somebody who makes some kind of robot decides that, well, I have two ways of getting people to pay for it. Either they can pay for it up front or they can pay for it month by month. But either way, I'm building this thing and I'm selling this thing. And I think that falls short in a lot of ways from the true promise of robots as a service. Because first of all, the customer doesn't know what they need, right? And so if you're coming in and saying, hey, I have this widget, do you want it? Do you want to pay for it up front or do you want to pay for it? Like it's not really truly as a service. As a service means like you abstract away the complexity of the choice and the decision making and all the maintenance and management, and you turn it into a real service offering. The second part is that I think there's also a fundamental mismatch in the DNA of those types of companies with each other. So I like the example of Boeing. So Boeing, back when it started, was both an aircraft manufacturer and an airline. Like they had to do both of those things together. And then eventually those two things had to split up, and Boeing became Boeing, the aircraft manufacturer, and the airline became United Airlines. And it's a completely different skill set to manage and maintain and run a fleet of airplanes, and to sell tickets, and to have loyalty programs, and to do in-seat video, and like all the things that you need to make a great airline experience. is very different than the skills that you need to build aircraft, right? And I think it's rare that those two things are in one company. And so what we're seeing for the robotics world is similar. It's like there are a lot of people who are making aircraft, for they're building robots of different sorts. And we see that number of companies doing that going up exponentially. Every day, there's a new robot that does X or does Y or does Z. And we're really enthusiastic about that. But we, as a company, have kind of adamantly decided that we're not in that camp. We're in the other camp of we're the airline, right? Like we run and operate and maintain a fleet of aircraft of robots, sorry, and we operate them to generate outcomes for our customers. And there's a lot of things that you have to do in order to do that well. And that's it's just two different kind of sets of DNA. And I think what we'll see little by little is companies will have to ultimately pick one or the other. Like either you're building a new device and a new piece of equipment, or you're operating that equipment and generating value out of it. It's hard to do both. The same thing happened in almost every industry. If you look at, Caterpillar, like they make agricultural equipment, they don't run farms, right? All the companies that make mining equipment don't operate mines. Like it's like two separate things. Like one is you make equipment, one is you operate equipment, and it's just a different business.
Interesting. And then on that standpoint, are you seeing any particular robot manufacturer with better technology? I think it's interesting that robotics has always been, somewhat, it's definitely not a winner take most environment. Most hardware is not that. But as we transition to, more software defined robots, are you seeing anyone, with outsized capabilities there or not yet?
I think we are at the beginning of the explosion of robot vendors, because it used to be, like you said earlier, like 90% of robots went into auto manufacturing, and within auto manufacturing 90% of robots either did welding or painting. Like that's it. Like that was the market. And so naturally, like some companies emerged that were really good at building robots that did that. They built distribution channels to allow them to sell the robots to the people who needed that. And like that business worked really well. But a lot of those foundational assumptions are changing. Like you said, with software defined kind of like robots that are more intelligent and adaptive, with hardware costs dropping really quickly, like most of the components that go into my smartphone are basically the same components that go into a robot. Like it's cameras, it's chips, it's sensors. The only difference is you have some motors and grippers, but like that's pretty minimal in terms of the cost of the system. Chris Anderson talks about like the peacetime dividends of the smartphone war, right, being applied into all of the different types of smart hardware. And I think that plus, I guess I would call it like the peacetime dividends of the self-driving car war, right? Because like all these people invested billions and billions of dollars into self-driving cars. And as a result of that, like we got way better, motion planning software and way better, edge processing chips and way better LiDAR and like all these things started to improve drastically. And those things are all going to pay dividends when it comes to robotics. We're going to use those to, and not we, I mean, lots of people are going to use those to build much, much better robots. And so I think that the relative differentiation between the hardware vendors on the robot side is going down. And I think we're going to see a lot more specialization, people building robots that are specialized in a specific type of task. And I'm excited about that because I think it means robots will get better for everybody.
Yeah, I hope so. And it is incredible. The cost declines, as you're saying, the cost declines for the hardware for robotics is pretty dramatic. So, definitely opening up the door to manufacturers that are not, producing high volume, high priced items now have the ability to actually automate from a investment standpoint.
Yeah, and I think on the other side, I think a lot of the robot manufacturers will see some margin compression because they're all using very similar hardware and similar components, and it's going to be hard to charge outsized prices on your robots unless you have some meaningful differentiation. And in some cases we have that. Like I think like Fanuc is an example of a company that has a fantastic service network, a fantastic maintenance network, fantastic integrations, and so they're able to get a really good premium on their robots that they sell because it's easier. Like your life is easier if you use a Fennec robot. And I think we'll see that people will have to build similar capabilities in other applications too.
And then as we're winding down here, the question that everyone asks me anytime you say automation or robot, you get this question, and you've got firsthand experience. Are robots stealing and destroying jobs?
You probably have a better answer than I do on that one. I think the data shows a very clear answer to that. It's very, very clearly no. Organizations that implement robots see over time increased demand for humans. Countries that implement robots see over time increased demand for humans, right? So I think it's directly correlated, and it creates opportunity. So, like the example that I gave about factories that go from a 2-shift operation to a 3-shift operation are a great example. All of a sudden, as they go from a 1 shift to a 3-shift operation, they need more marketing people, more salespeople, they need more delivery drivers, they need 100 different things. So I think overall, like this is really, really it unlocks human potential. The other thing that is really clear to everybody that's in the manufacturing industry is that these jobs that robots are doing are not jobs that people want. Like every factory that we go to has 30-40% unfilled heads. They pay giant bonuses for anybody to sign up to take one of these jobs, and nobody wants them. A lot of these factories have 200% annual turnover. So that means they hire for the same job twice a year. It's very, very, very clear that like humans are not interested in these jobs, and you have to like cajole them and pay them lots of money to come and do them, and then they don't stay. So I think robots are necessary for us to see the kind of raising of the waterline for everybody that we want to see. But I think that's kind of my firsthand experience. I'm curious if you've seen other stories or other versions of that.
Yeah, I mean what you said is true from what we've seen. I always like to think it's amazing that without automation at the base level, like 70% of us would need to be working in agriculture, right? So it's like you need efficiency. All right. So then it's like we started using animals. And then, okay, now you have some people that can go and they can start doing other things. And then you get a tractor and you get more and more people. And so it's like this at the very base level, it's like automation frees us to do other exciting things that push civilization forward. And then the other big trend that we see is automation takes non-market activity and puts it into the market. And so, pre-tractor is like, you always see the statistics of this percent of the population worked in agriculture, now this does. And it's like the majority of the people who stopped working on farms because of the tractor were unpaid family members, right? So you're taking this huge non-market activity, and then all of those people are free to enter the market. And we think, something similar is going to happen with autonomous vehicles, if you think about it. Right now, there's anyone who's got a license and is not a truck driver or a taxi driver or an Uber or Lyft driver is an unpaid participant in the market, right? Like we waste, all of us like 30 minutes a day driving, and no one's paying us to drive. And as soon as you get an autonomous vehicle, every one of those people is now going to pay for that service. So you're taking this non-market activity, you're bringing it into the market. Same thing with food service automation, right? No one pays us to clean up after ourselves at home or to go get groceries. But if automation makes it economic enough, then we'll pay for that service. So there's this really interesting dynamic at play from that angle.
That's cool. Yeah, I hadn't thought about it that way. That's really interesting.
Last question from me here is, what excites you the most in the next 5 years? And or if you'd like to wager a prediction for the next 5 years in robotics and automation.
I am really excited for the AI aspect of robotics. Like you said, right now we haven't seen a world where AI plays a really meaningful component of robots that are deployed in the real world. Like there's a lot of really cool academic stuff that's going on, a lot of cool research things that are going on. But I'm really excited for the time that I think will come in the next 5 years, where you can use natural language or maybe some gestures to just explain to a robot what you want it to do and see it follow your instructions, basically. And I think there's a few things that have started to enable that. I mean, you've seen with GPT-3 and like OpenAI's Copilot, or what's it called?
For programming.
Yeah. You can describe the program that you want. It writes the program for you. I think those types of tools are getting so much better so quickly that they're going to enable us to, with just normal human interaction, instruct a robot on our needs and see it kind of execute that. And then we can give it correction. We can say, hey, actually don't pick it up, don't pick up my cup this way, pick it up the other way. And it'll start to execute on that. And so that's something I'm really excited to see. I think we're very, very close to that, closer than most people realize. And I think that's going to be a sea change for robotics applications.
Well, we're excited to see it happening. Is there anything I didn't ask you that, the people must know?
No, I don't think so. Check out our company, www.formic.co, if you know anybody who needs a robot. And that's the only thing I can think of.
And how do we follow you? We ran into each other on Twitter. How do people follow along?
Yeah, follow us on Twitter, follow us on LinkedIn. Look forward to hearing from all of you.
Great. Thank you, Saman, so much for joining us today.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.